Hey, hello everyone. Welcome to this new edition of AI on Pi Day. If you joined a few minutes before, you had a very calming snow, and just making sure that I'm letting people in as well. So my name is Jean-Georges Perrin, or JG, and I'm going to be your host today, and maybe eventually a little bit of a moderator if we have to. And so I'm actually, we have two co-hosts. We have Ralph, who you probably already met or probably read his wonderful AI magazine. Say hello, Ralph.
Hello. Hello, everybody. This is Ralph from Barcelona joining.
Yeah, so Ralph does not have this view right now, okay, just to make sure. My second host is actually my oldest son. Hello. So you won't see a lot except you've got the broadcast view. Okay, so today, I see plenty of friends coming. That's great. Plenty of old friends and new friends coming. So today, what we're going to do is we're going to talk about AI, as you would expect, as AI on Pi Day. And in a few minutes, we will have our friend Bill Higgins join. Bill is going to talk to us about what he's doing at the IBM Watson as the R&D, as a director of R&D for IBM Watson. So that's kind of pretty cool. So he's going to talk for about 40 minutes. And then after that, we've got plenty of time for Q&A. And I hope you are preparing all your questions. And then after that, we think that Bill will stay and Rob Thomas will join for half an hour. And then we will discuss a little bit all together about all that and try to understand all the questions and that you may have. If you're on Slack, we will monitor the Slack channel as well, which is AI on Pi Day on Slack. If you are not on Slack, we will also monitor the chat here as we go along. So that was kind of the introduction. People are still joining. Anything to say? I'm pretty sure you've got requests for the forecaster.
Yeah, I just put the Slack channel in the chat, and of course, the Forecaster magazine is kind of my baby. I really do this almost every month with a lot of heart and a lot of sweat and a lot of enthusiasm, gathering topics in the I/O field, getting the gems out of GitHub, also promoting like old stuff. You really liked the one where I was writing about Dune. Do you remember that issue?
I remember the Dune picture. That was kind of pretty gorgeous, actually. Yes.
Yeah, and so I invite you to read into it. It's PDF format. I try to post some, except from some summary of the forecaster on LinkedIn also. And yeah, if you guys have something to tell, that feel free to drop me a note. Email address is ralph@aidaug.org. And I would be happy to receive your content and to write about it.
And right now, the forecaster is being sent to like more than 400 people. It's not small and it's not huge, but it still has room for your content as well.
Yeah, we're actually constantly growing it, and right now I think 482 are subscribed to the email list and would receive it. And of course, a lot of high-profile professionals, but also developers, non-technical people, technical people. So it's quite a mixed audience there. Yeah. Let me know your content if you have something to write about, AI, data analytics, would be happy to engage. Yeah.
And where can we find it, Ralph?
I will post the link in the chat. It's on the AIDAUG website and it's member content. So if you're a member and signed up, then it's right in the member content section.
And I hope you're all familiar with the AIDAUG website. It's aidaug.org. You're probably all members, or most of you are. It's great to see all these friends joining. And speaking of friends, I don't have it in front of me, but there is this really great book that just came out by Karen Kilroy. If you remember Karen, she gave a talk last year. She was writing on a book, and her book is now being published. Like Karen, what was it, like 2 weeks ago or something? And so I read it, and I don't read a lot of books, but I really loved it. And that's a book here. You can probably see it. I know, it's blockchain tethered AI. Okay, so the whole idea of controlling AI through blockchain. I think this is really a great idea and a great try a little bit better. That's with Okay. So that's in the news of our members. Karen has been a member for a while now. So this, okay, I see more and more friends joining. Oh, you're welcome, Karen.
Yeah, people from Denmark, Rick is here, Philip Hornung from Germany is here.
Yeah, we've got people from all over the place, including this place. So just a little bit about the snow here. Okay, it's not just to tease you guys where it's probably warm and sunny and there it's cold, but I live in upstate New York. Last time when we talked for the last edition, I used to live in North Carolina. Between them and now, I moved to upstate New York. But it's a very rural place. So to get internet, I use Mr. Musk internet via Starlink, and it's a little bit spotty from time to time. So if you lose me, not big deal. You've got Ralph. And anyway, you're not here to listen to us. You're just here. You came here to listen to our speakers, Bill and Rob. Okay, so all good. But I think the snow is kind of soothing and calming. And when you're organizing such events, you're a bit of a level of stress just before because the sound doesn't work the way you want. So this is kind of the challenges we're having. Okay, we are at 11. And Bill, are you ready? Did you finish your last slide?
I finished my slide and I had half a bagel. I had a very productive 4 minutes.
That's great. And I love bagels, especially because here they're really good. Okay. So, Bill, I think the floor is yours. I'm going to shut up because whatever I say is not interesting anyway. So go ahead.
Yep. So nice to see everybody here. I'm Bill Higgins. I lead the Core Watson platform for IBM, which is now, or as will be announced in 2 months, now a joint IBM Red Hat platform with a lot of the code that we've created over the past 4 years going to open source in a few months. Been at IBM 22 years, and another relevant thing in my past for this talk is 2 jobs ago in the mid-2010s, I led the rollout of the modern development tools at IBM, GitHub, Slack, et cetera, which is a key enabler for some of the stuff I'll talk about today. So what I'll talk about today is how Starting about 4 years ago, we had to create, or we had to basically rebuild our AI technology almost from the ground up, not quite from the ground up. And so I'll tell that story because I think it's kind of an interesting story about culture and architecture and doing hard things. All right. Can one person confirm verbally that you can see my screen?
Yes.
I can see it.
Thank you.
All good. All good.
And Rob and I coordinated last night. So Rob Thomas is our SVP of software and also sales. In his talk, he sent me his charts last night, and it was a pretty nice kind of logical connection between my talk and his talk. But I just added one chart at the end, or two charts at the end, to make it a little bit more seamless in the segue. So this will talk about the last 4 years, and then Rob's talk will really get into the vision for the future, not near future, not like 5 years from now future, like 2023 future. Okay. So I always start this talk by talking about the eras of AI as I think about them. So in my mind, there's 3 eras of AI. A lot of people don't realize that the field of AI is almost as old as the field of computing. So if you think about digital computing, it basically begins in the early 1940s as, World War II was happening, especially around cryptography. And then AI was founded as a field in 1956 with this famous Dartmouth conference, where some of the all-time legends of computer science, like Claude Shannon and Marvin Minsky, got together to establish AI as a field of study and a field of research. Incidentally, a IBMer organized that conference. And so at IBM, we have been working on AI since then. And some of the black and white pictures in the upper left here are some of the milestones, like some really early work on natural language processing, speech recognition, visual recognition, machine learning, and some visible highlights like the Deep Blue computer that beat Kasparov at chess in the 90s, and culminating with the Watson Jeopardy system, which beat the Watson human champions at Jeopardy in 2011. So I consider that Watson Jeopardy the demarcation of the end of era 1, because Watson Jeopardy was representative of AI crossing a threshold where the joke had been before 2010, 2011, that AI was always perpetually 10 years from being useful. Like if you ask, when will AI be useful in 1956, they'd say mid-60s. You ask the same question in the mid-60s, they'd say mid-70s. And it was only in the 2010 timeframe where explosion in data from mobile devices, Internet of Things, dramatic reduction in the cost of compute and storage because of cloud computing, and then new algorithms with deep learning. And these things are all interrelated. They're not discrete things. Really caused AI as a practice and as a set of technologies to cross a threshold that then in the 2010s, people actually started applying them en masse for real world systems. For IBM, this meant acquiring companies. It meant starting new organic products that were AI first, and it meant starting whole divisions with AI at the center of them. This era was marked by hits and misses because it was such a new technology. We frankly didn't know about the product market fit and what it should be. And also inside IBM, it resulted in a tremendous amount of technical fragmentation. So during this era, Watson was really a label, not a tech stack. And then that brings us to 2019, the platform era. So as you all probably know, in 2018, IBM acquired Red Hat for $34 billion. The acquisition closed in 2019. And we started down this, what was then a new strategy called hybrid cloud and AI. And that's where I enter the story. So, like I said, in the 2010s, I had led the rollout of these modern development tools at scale, GitHub Enterprise, Slack, Travis CI. And in some ways, that's not novel because these are popular tools. But what was novel was the scale. So as an example, with GitHub Enterprise, when we started adopting it, it was only qualified for 10,000 concurrent users. Well, IBM has 75,000 developers. So we had to essentially re-architect GitHub twice to make it work at our scale. Similar, we had to work with Slack to re-architect and redesign Slack to work at our scale. And so through that, I got to know Arvind and Rob, so Rob, our next speaker, pretty well, Arvind, our CEO, because they were the executive sponsors in development for scaling those tools. As you could imagine, getting licenses for 75,000 GitHub users and what was then 350,000 Slack users ain't cheap. And so we needed those powerful guys to basically work at the top of the company to get funding for it. But it also meant I got to know them really well because we worked together fairly closely for 2 years. And so when they started down this hybrid cloud and AI strategy, they said, hey, Bill, you just got everybody to adopt these new tools. Now get them to adopt Watson. And I said, but I don't have a background with AI. And they said, that's fine. There's no shortage of AI people, but what we need is a cultural transformation. And like you did it with tools, maybe you can do it with AI. And so the goal of this strategy is listed here in the expected benefits. So the first thing is differentiate IBM products with AI. Like AI, when used wisely, and for certain use cases, can lead to a much better experience than traditional programming. And the other, and back then in 2019, there was only on the order of maybe 10 or so products inside IBM that made heavy use of AI. And we have hundreds of products. So the idea was, how do we make this more just a way of building applications, similar to how in the 1990s, at some point, the web was the web as a technology platform was new. And then 10 years later, it was ubiquitous. So accelerate that for IBM with AI. The second thing was to drink our own champagne. So it's not very credible when you try to sell a platform to somebody if you don't use that platform yourself. And so the idea was, if we can use this ubiquitously inside our product portfolio and actually have demonstrably better products with better user experience and better financial results, that's a pretty compelling story to take to customers and to, potential customers. But there were these two pretty massive inhibitors. So the first thing was, because I didn't come from an AI background, I assumed that the problem was that nobody was doing AI, but the problem was that everybody was doing AI, but with their own bespoke stacks. And with the benefit of hindsight, I realized this is sort of the natural effect of Conway's law when applied to a hierarchical organizational structure. And we eventually fixed that problem, but that's part of the story, so I won't spoil it now. And then the second one is hybrid cloud. So prior to 2019, our strategy was what we called Watson Developer Cloud. So really a focus on the IBM cloud with the Watson services as the showcase to try to get people there. Then in 2019, we made the pivot to hybrid cloud because we recognized that every enterprise on the planet ends up needing a hybrid cloud architecture, because like Division A is all in on AWS, Division B is all in on Azure, and then there's some systems that won't be moving from the mainframe anytime soon. And so rather than just saying, hey, the answer to your hybrid cloud problem is to move everything to IBM cloud, we said, let's work with customers to take on that hybrid cloud problem head on. Just like, in the 1990s and 2000s, we helped customers take on their problem with operating system heterogeneity head on with WebSphere. But what this meant was that we required a portable AI stack that could run anywhere, literally anywhere, in IBM Cloud, in AWS, in Azure, in Google Cloud, on premises, on the edge. And back then, we didn't have a stack that had that portability characteristic. And so really the way I'd summarize the 2019 situation is we lacked a stack. So the first thing we did to try to rectify this problem was attack the problem in the domain of natural language processing. For those of you not familiar with it, natural language processing, or NLP, is using typically machine learning techniques, not always, but typically machine learning techniques, to be able to make sense of textual human language. So think like an email or a Slack conversation, something like that. Both understanding what the person is saying, but also things like the sentiment and emotional content of the textual human natural language. What this chart here from my colleague Laura Kitikariu, who's our distinguished engineer for natural language processing, shows is the history of natural language processing investments at IBM from 1990 to 2016. And you don't have to read every word on the chart, but the key thing to recognize is that we've been at this for a while. We've made a bunch of investments, and the lines don't converge. So every divergent line represents a separate investment and innovation stream for NLP at IBM. And the practical consequence of that is, if you look at something like IBM SPSS, text analytics is just one example that happens to be at the top of the chart. if the product team makes a $5 million investment in NLP for this product and they end up doing something really amazing, this is where it ends. So basically we were fragmenting an aggregate large NLP investment across many different investment streams, and therefore none of them was great. They were all kind of like, I'll say on average, mediocre with a few bright spots. And the people who worked on them, of course, wouldn't say that. So then in 2019, I joined the Watson division, and also Dakshi Agrawal joined the Watson division as our CTO. And he set this goal here that I'm just going to read because it ended up being profoundly impactful. We need an NLP stack to be adopted all over IBM that contains all of IBM's best NLP, provides a path from research investments to product, and offers standardization of critical NLP components. Pretty reasonable goal, but if it were easy, we would have done it in like 2005. But the punchline is we achieved that goal, and I'll get into the how in a minute. And over the course of 2 years, from 2019 through 2020, this picture changes to this picture. So we ended up having a common NLP library with all of the new research investments flowing in here, as well as packaging up previous research investments. Then with techniques that I'll get into in a minute here, it was broadly adopted by about 18 IBM products in the first year or two, which was unprecedented. So how did we do this? At some point, a colleague at IBM, we were talking about this problem of fragmentation and like, why won't anybody work together? And why are we so bad at reuse? And at some point, one of my IBM colleagues made a joke that turned out to be like profoundly wise. He made the joke that the only way you can get two IBM product teams to work together is in open source. And while he said it as a joke, we actually realized he was right. But there's a very critical tacit assumption in his statement. Most open source projects are not successful. If you look at github.com and just do a search on any GitHub repo with an open source license, 99.99% of them have like 1 star and 1 contributor. So when he said you can only get 2 IBM product teams to work together on open source, what he meant was successful open source projects like Kubernetes, like Apache Web Server, et cetera, Eclipse. And why is that? So we looked into characteristics of successful open source projects. And 201, they had these 3 things in common. They had a great developer experience. They had, in the sense that you can get up and running with the tool in like 5 minutes or an hour, maybe, because they use standard component registries like PyPy for Python. And they optimize for a great out-of-the-box experiment with sample applications, et cetera. Like think of something like Ruby on Rails. So they have a great developer experience. Second thing is they have a great community that is welcoming to people, that invites people in, helps them get started, helps them get unstuck, and just generally provides that human connection that is so important to humans in general, but especially creative people doing hard things. And then the third thing that they all had in common was a great modular architecture, which is a prereq for ease of use on the contribution side. So while most people just use open source projects, of course, a lot of the magic of them is that a diverse set of individuals make contributions to them. And it's far easier to contribute to a small thing that does one thing well versus a big pile of spaghetti code that does 1,000 things not very well. But in 2019, we couldn't just jump to open source. Like we couldn't rebase all of our products on, a smattering of AI open source projects. Even though there was a lot of AI, great open source AI, it was just a step too far at that time. But what some of our colleagues figured out was there's this concept of inner source, which is simply applying open source good practices and principles and culture. But instead of having a bunch of companies collaborate on a common IP stack, you have a bunch of divisions collaborate on the common IP stack. And so what we did was we had studied all these great open source projects, and then we asked the question, okay, how could we use the same best practices like great developer experience, great community, and modular architecture and great contribution experience to get to a common AI stack? And these are the 3 principles, which I'll just go through really quickly because they're really important. This is like after 4 years of thinking, we've got it down to these 3 things. So the first thing is that differentiation requires focus. We're in an incredibly competitive industry, as you are as well. And if we're diluting our investments by having 20 of everything, then it's not going to allow us to make investments on actually differentiating capabilities. So rather than have the security group create a half-ass NLP stack, let's just give them a great NLP stack so they can focus on better security using great NLP. Second thing is, none of us is as smart as all of us. I'll tell a concrete story that really proves this point. But collectively, even though the first picture was fragmented to all hell, we actually had a lot of good stuff, like a lot of great stuff in aggregate. But if it's not brought together, then it doesn't matter. So how do we leverage that wisdom of crowds and the innovation that happens when different people are solving different problems? And the third one is really the cultural piece, which is 95% right is more important than 5% wrong. So what would happen before is, say there was a ostensibly reusable component, like an ostensibly reusable NLP, a product team would walk up to it and say, okay, I need it to do these 10 things. And the common component team would say, well, it does these 9 things. And then they say, okay, therefore I have to build my own. So the inner source culture and the open source culture says, if it does 9 out of 10 things right, that's awesome. And instead of walking away and doing your own bespoke stack, make the contribution with your actual developers to get the 10th thing. And then you get the common stack, and the common stack gets better because of your diverse use case. Okay, so this is the year 1 stats for Watson NLP. So we applied all those best practices. We had a pretty awesome little team. And within the first year, we had 12 full-time maintainers from different groups, some from research, some from the software group. Then we had 700 users we just counted that as people in the Slack channel. Some of them were actually adopting, some of them were exploring. And then the really interesting stat is 50 contributors. So these are people whose full-time job was not NLP, but they made some contribution, whether it was a data set, whether it was an international language, non-English language, whether it was a bug fix, et cetera. And this is really the model that you want, these kind of rough percentages in terms of the funnel of people who are just using versus contributing ad hoc as needed, and people who are full-time. And the punchline stat is that we did a calculation about how much it costs us to assemble the common NLP stack, which was $2.4 million in the first year, and how much cost avoidance we could claim by when product teams adopted a feature. So we knew how much each feature cost. So each time a product team would adopt one of those features, we'd claim that as cost avoidance. And so it's about a 3-to-1 ratio, which directly translates into time to value for the products adopting the solution. So if you think about differentiation of a product, like a security product, it's basically how good is it and how soon can you get it to market? And by having a really great NLP stack, we were accelerating product teams to make their products better with high quality NLP, which was helping them get more interesting features to market faster, which is key for a software product to be successful. So this is the coda to the Watson NLP story. And this is the thing I mean by none of us are as smart as all of us. So in summer 2021, the New York Times sports reporter, sometimes it feels like that, tech reporter Steve Lohr put out a story called Whatever Happened to IBM's Watson. And it was a retrospective on the first 10 years of Watson. And the framing was essentially, like Watson Jeopardy was this really unique moment in the world. And then IBM was talking about curing cancer with Watson, but you don't really hear about it that much anymore. And this was circa 2021. And so the end of the article had this awesome coda. So I don't know if people have heard of Oren Etzioni, but if you haven't heard of him, he's like a very famous, very accomplished AI guy, like longtime AI guy. And he would also be the person who, when in the 2010s, IBM would make some claim about what Watson was going to do, Oren Etzioni was always the guy who debunked it on Twitter. So he's like a longtime Watson critic for the overpromising. And so what Oren said, they hired Oren to test quote unquote Watson. And I say quote unquote, because remember back then we didn't have a stack. It was more of a label. And we got lucky in that Oren tested the natural language processing products like Watson Discovery, Watson NLU, which by this point had been rebased on the common NLP stack that aggregates all of the goodness of NLP from around the company and from open source. And so what he found in his testing was that the IBM natural language products performed as well or better than Amazon, Microsoft, or Google. So the coda to the article was that IBM, despite the first 10 years hand-wringing in the rest of the article, at least for these technologies, IBM's gotten its act together. And that was really validating to us inside of IBM because it was too early to talk about this publicly. but it was really good validation that the strategy was working. Because remember, this wasn't net new, like $20 million of investment in NLP. This was aggregating what already existed and taking some new stuff from IBM Research. So we already had literally world-class NLP, but only if it comes together as a common stack. Okay, so now we get to the next part of the story, which is an AI operating system for the enterprise. So after we started having success with NLP, everybody, the team, the executives, the other IBM product teams started asking the obvious next question. If it works for NLP, why shouldn't it work for everything AI? In fact, why shouldn't it work for all software, all platform software? And we said, well, in theory, it should work for everything. And so this is the process we use, which I think generalizes pretty well. So the first thing was we zoomed out and we looked at all of the AI-centric products that had been created in the 2010s, things like Watson Assistant, Watson Discovery, and Watson NLU. And whenever there was a logical capability that occurred at least 3 times, we wrote that down as a candidate for a platform capability. What we didn't want to do was just go to a whiteboard and say, what should an AI operating system be, and just make it up. So we worked backwards from what had been created out of necessity in the 2010s, and I'll show you the end result in a minute here. Then the second thing was we had a principle that we never want to start from scratch for a common component. As tempting as it is to start from scratch, your project gets killed before you ship anything interesting, because the portfolio of fragmented technologies represent literally hundreds of person years worth of effort and investment. And so you can't replicate that in a feasible manner. But the third thing was we took that code and we refactored it extensively so that it actually was a coherent system with a common architecture. What we didn't want was to have what we call a Frankenstein system, where you have a bunch of different things kind of bolted together and it kind of sort of works, but it's incoherent. So we did a lot of refactoring to get to a coherent architecture. And then now we get into the actual adoption. So embed the AI platform tech into IBM products, which was the status quo since 2019. But then as of last year, Rob, who will be talking to you in a minute, made the call that it's matured to a point that we should also sell it to other software companies. So like PayPal, for instance. What our observation is if IBM, who has a R&D budget in the tens of billions and has a historic research capability that's literally invented parts of AI, if our product teams struggle with AI, then surely companies who don't have those resources struggle with AI. And in fact, we didn't just have to speculate on that. We were hearing that from other companies. And so then we made the call in 2022, last year, to start commercializing it. And in fact, if you do a Google search on IBM embeddable NLP, you'll find the commercial version of the Watson NLP that I just talked about. And then finally, activate the inner source and open source ecosystems to accelerate the flywheel. So this is a visualization of that. We have 3 upstreams. We have IBM Research. So all of the AI research investments now funnel into the common stack, which is also a great control point. We are aggressively adopting open source, and we'll be contributing to open source, which I'll get to in a minute. And then when a product team does something really good that can be generalized, we have a process for taking that, harvesting it, and putting it into the common stack. Internally, the common stack is called Watson Core. This is not a name we use externally, but it's just the name we use internally for the common stack. You'll hear about the naming of the commercial common stack at our Think conference in 2 months from now. It won't be called Watson Core, though. And then downstream of that is IBM products and ISV products. So we collect the innovations, we refactor them to work in a coherent stack, and then with a great developer experience, we help IBM products as well as third-party products infuse AI to differentiate those products. So this is the stack as it stands today internally. Some of this you can buy externally. Some of it is not yet available externally. Eventually, all of it will be available externally, some as commercial components, some as open source. But let me go through this really quickly. So the left is really the application level functionality. So what we realized is that there's this recurring pattern that AI is useful for data modalities that are too complicated for traditional programming. So as an example, human natural language in either the written representation or the spoken representation. You just can't write enough if, else, while statements to make sense of human natural language. So these data modalities, textual human language and spoken human language, lend themselves to AI. So we started creating common components for that. A very different example is time series. So time series data, think of this as like log messages, tends to have the same characteristic in that it's semi-structured. It's not unstructured. Otherwise, it would just be noise. And you can extract valuable signal from that if you can make sense of it. For example, anomaly detection in an IT system. The other algorithmic library that's a bit different is trustworthy AI. So trustworthy AI algorithms deal with things like fairness, to avoid bias in AI systems, explainability, to make sense of why an AI system made the decision it made, which is not just nice, but required for regulated industries like insurance. And finally, adversarial robustness, because there are still bad guys in the world and they like to attack AI systems just like they like to attack other systems, but there's different attack vectors. So let's defend against those. The reason this purple box is at a different kind of axis is because it applies to all of the data modalities. So you need explainability for NLP, you need explainability for time series, et cetera. So the design of the system is such that trust is so I think of this overall picture as an AI operating system, just like iOS is a mobile operating system, in the sense that you have both just sort of like kernel level tasks, but then you also have application level libraries that accelerate the creation of useful AI applications. And by AI application, I simply mean any software application where one or more use cases can only be achieved with AI, like a chatbot, for instance. So trust is meant to be part of all of these, both built into these as well as for custom models that have nothing to do with these pre-built models. The middle part is kind of the guts of the AI operating system. One of the I'll say what it is, but then I'll explain why it's important. So it's basically two things. It's a runtime to bind AI into internet scale web applications or edge applications. And it's a compositional runtime, very similar to Eclipse, to help AI models work better together. So when we were reflecting on the AI applications that were built in the 2010s, like Watson Assistant, they're highly compositional. And I'll give a concrete example. When you ask a Watson Assistant chatbot a question, like if you go to the CVS website and say, when can I get a COVID vaccine? Before I knew how AI worked, before I came to Watson, my naive assumption was that there would be an AI model that knows how to speak. In fact, when you ask that question to the Watson Assistant chatbot, it gets routed through 12 AI models in a dynamic orchestration. One model extracts the nouns to start to make sense of what you're asking. One model does classification about what kind of topic area is this on? Like, are you asking about COVID vaccines? Are you asking about store hours? One model deals with the particular aspects of the customer vocabulary. Anyway, there's like 12 models, and you have to route through them with sub-second response time, which is hard. But then if you look inside these systems like Watson Assistant, there's just all this code that all it does is make Model A talk to Model B, make Model B talk to Model D, make Model D talk to Model A. And so what the team realized is we could create an architecture and a protocol that allows you to achieve that composition characteristic, but with just a few lines of code. So as a concrete example, natural language processing gives you sentiment analysis. So like, is the email that JGP sent me happy or sad or angry? So sentiment analysis is one feature of NLP. Time series gives you anomaly detection, like did something strange happen versus what we would expect to normally happen. If you put those two things together, you can talk about anomaly detection of sentiment over time. Like, has there been a rash of angry emails much above the norm that we should look at as a systemic problem? Then finally, if you bring trust in the picture with explainability, tell me why, explain why we're seeing anomalies of sentiment over time. So prior to this system, what I just described would be a 12-month IBM consulting project. Now with this system, it's about 12 lines of code. And that's because we've architected the composition architecture and the protocol to make it possible to do that. It's just good architecture. And the news I'll share with you today is that this compositional runtime is one of the things that we're going to open source in the May timeframe so that it can live at the Red Hat layer, so that we can have a common runtime for both just the internet scale computing things, but also the compositional runtime. So look for an announcement around the open sourcing of this, and would love if your company would want to use and or contribute to it, because we didn't create it for fun. We created it out of necessity. If there was something that already did this in open source, we would have just used it. All right. So now I'm going to zoom out a little bit and just talk about kind of innovation in general, because I think this story I'm telling you is a good story of innovation, but there's some lessons that generalize even if you're not building an AI operating system. So in 2021, about 2 years ago, so like midway through the journey to date, we started in 2019, now it's 2023. So this was about midway 2021. All of a sudden, very powerful people in IBM, senior vice presidents, our general manager of strategy, started talking about inner source in their talks. And for us, this was really strange, because we knew why inner source was important to us to make any of this stuff work, to defragment the AI portfolio, but we considered it an implementation detail about how we work. And so it was just very strange to us that these very powerful people were talking about inner source. But now, with the benefit of hindsight and actually talking to them, I understand why. So this is a picture of an innovation flow. So any innovation starts with exactly one of two things. A market signal. So this is something like COVID happens, or GDPR becomes a law, where something just changes in the world, which creates problems, but also creates opportunities for technology to help address those problems. The second thing is an upstream scientific or technical advancement that allows you to allows you to revisit existing solutions. And my favorite example of this is in 2001, an Apple SVP was in Japan getting a tour, I think from Samsung, of technical innovations. And one of the things it's Toshiba. And one of the things they showed him was the world's first 1.5-inch hard drive. He saw that and he said, 1.5-inch hard drive with 3 gigabyte storage, that's about 1,000 MP3s. And that was the origin of the iPod, which of course then became the iPhone, et cetera, et cetera. But it started with that 1.5-inch hard drive, and that Apple executive having the good sense to realize that now we can do portable music in your pocket much better. So then the purpose of IBM research, we say the purpose of IBM research is two things. It should be the engine of organic innovation for IBM, and it should advance computing. So these people who work in IBM research are always observing the world, like both changes in the world as well as changes in technology, especially breakthroughs, some of which we create ourselves, some of which come from other companies, other academic institutions, and turn those into technology. Now, here's where it broke down before inner source. Everything that happened here was done in a highly bespoke way. And so the joke I make is like the pile of Scala code that exactly one human on Earth understands. But it would often do interesting things and useful things. But because it was written in that heavily bespoke way, and frankly, a lot of times just not good software engineering, the time to go from here to adoption in an IBM product could literally be measured in years. So the joke I always make is that the day the IBM research press release goes out about the breakthrough is the day the product rewrite begins, because it's like a big wad of Scala code that can't run in production for broad use, enterprise use. But anyway, if you go through this funnel at all, it will lead to revenue and some brand impact, because like even before this effort, we did get AI into products in useful ways. It was just very slow and not scalable. So the reason those SVPs and GMs were excited about inner source is that without realizing it, we actually had cracked the code on how to massively scale and massively accelerate the innovations of both IBM research, but also product teams and open source communities into first the IBM product portfolio and the ISV product portfolio. And the way that it works is, if you remember me talking about those characteristics of successful open source projects, great developer experience, great community, modular architecture for great contribution experience, it allows you to have just common stacks where innovation, like say a new AI algorithm, can very easily get into the common stack because of the community and the good contribution experience. And then because of the good developer experience in the community, very quickly get into IBM products. So think about like a new natural language processing algorithm from IBM research. Before, it would be a one-to-one relationship with an IBM product team and a very slow one because it would have to be rewritten or partially rewritten. Now that algorithm goes right into the Watson NLP stack, and we do have to do the hardening, but that's more just like, okay, they didn't cover some exception cases or they don't have good test automation. That's much easier than rewriting a big complex thing. And then because inside IBM, dozens of products have adopted that, they get that new algorithm the next time they bump their build. So we literally have gone from years to weeks and sometimes days for innovations to get from IBM research into mini products. And especially as this gets adopted by other software companies, and there will be some other big announcements around, think about some major software companies who've adopted this. The speed through this path and the scale across many different products, it's like 100 or 1,000 times more impactful. So that's why those SVPs were so excited about it, because we cracked the code on how to have like 100x or 1,000x impact of IBM research, which, if you know how much money we invest in IBM research, ends up being a pretty material impact to the company's bottom line. And these things will take time to actually show up in the bottom line. Anyway, so now zooming out on the topic of open source and inner source. So when people got excited about inner source at IBM, on one hand, it was great because we did need the organizational support to get people to contribute to the stack and adopt the stack, et cetera. But we always thought of inner source as more of a waypoint than an endpoint, because what you're really trying to do is create a creative ecosystem, an ecosystem of creators, of designers, of developers who are making the common thing better. And most software today is actually commoditized, if we're honest with ourselves. We ended up doing a great inner source model serving system, but guess what? Like, we can't sell that. We can't sell that by itself. It won't make any money because the open source alternatives are, good enough that it just won't make that much money. So the goal all along was that we would do inner source first to get to the common stack, to get to the modular architecture, the composable architecture, the extensible architecture. But when the time was right, and when we had the right organizational support, we would open source most of it. So the fun news is that the time is right now. And so we're going to be open sourcing most of it in the May timeframe to correspond with our Think conference. What we will hold back is the actual next generation foundation models. So I'll get to this in a minute, but ChatGPT has created a unique moment in the world for people to start to realize what next generation AI can do. The technology underpinning ChatGPT, not all of it, but a good part of it, is something called foundation models, which is an architectural paradigm introduced by Google in 2017 with their paper, All You Need Is Attention. They called it the transformer architecture. Now we've standardized on the term foundation model, but just think of it as sort of the next step function in capabilities of AI. So we'll hold back the foundation models themselves, like the NLP foundation model, the code foundation model, but we're going to open source all of the infrastructure, model serving, compositional runtime, model training. There's some other stuff, but those are the highlights. And so this is how we think about it. There should basically be 3 types of code in IBM. The vast majority should be open source, either open source we're adopting or open source we're contributing to nurture the broad ecosystem, because as big as IBM is, the world is much bigger. Then for a set of things like the foundation models, we'll use all the same practices, but deliberately hold them back. We may do some partner collaborations with the inner source stuff, but that's a little bit too early. We got to get a little bit better at data governance first. And then closed source is stuff that's just not broadly reusable, like a UI panel in a product. And that's fine. But as much as possible, we want to shift to open source and inner source so that our product teams can focus on their user experiences and their differentiating capabilities rather than rebuilding NLP stack. This is a concrete first instance that we did in 2021. So we had, for model serving, we had two significant investments. We had one that kind of came from the Watson apps world, like Watson Assistant. And then we had one that came from the Cloud Pak for Data, Watson Studio world. And so what we did in 2020 was coalesce those into a common model serving stack that took the best of both. But then what we realized is there was this little nugget inside the Watson core serving stack called model mesh, which my layman's explanation of it is that in any interesting AI system, like in production, there's at any time hundreds or thousands or tens of thousands of models at play. And so what model mesh does is swap those in and out of memory based on usage so that you don't melt your servers. And it just makes the infrastructure footprint much less than it could be because it runs at a high utilization. So we talked to our friends in Red Hat and they said, we would love for model mesh to be part of our Red Hat open source data platform. So Open Data Hub, Red Hat OpenShift Data Science, et cetera. And so we did this first experiment where we donated model mesh to the Kserve group, and then Red Hat adopted it inside OpenShift. So this is how we go from inner source as a stepping stone to the ultimate destination, which is open source. And now in May, we'll do that for 10 times more stuff than just model mesh. Okay, so I think I'm going to skip the architecture deep dive. This just gets into some of the modularities, and maybe I'll spend a minute on this. So this is the kind of the big layer cake diagram of all the things, the AI operating system. But I just want to talk about one really important architectural point, which is key for composition to work. So one of the fundamental problems with tech in general, but especially a fast-moving technological area like AI, is that the rate of innovation is such that, and the rate of new frameworks is such that companies who are adopting the technology, whether it's AI or web framework, have this awful choice to make between always churning to replatform on the latest and greatest whatever, or to get stuck on a kind of like an older implementation that as newer stuff comes out starts falling behind. So the orange boxes represent a bunch of different implementations, some of them proprietary, some of them open source. But what we realized was for each of these domains like NLP, time series, et cetera, there's actually a very stable set of capabilities that this one shows NLP. So any NLP system that you get from open source or from a company will either have all or a subset of these capabilities: entity extraction, sentiment analysis, et cetera. So what we realized was just through good software engineering practices and software architecture practices of separating interface and implementation, which is like software architecture 101, we could actually have stable APIs, and then through a plugin architecture for the capabilities, then through a plugin architecture, be able to swap in different implementations. And this helps with two really big things. So the first one is that it allows our customers to stay up to date on the latest and greatest because we do the adoption so that they don't have to. And as these common stacks get adopted by dozens or hundreds or perhaps thousands of companies in the future, this will really allow us to be the trusted partner who makes sure that you're always on latest and greatest, even as new stuff comes out. So you can have stable APIs, and we'll do the hard work of making sure the underlying implementation keeps getting better. Like with the introduction of foundation models is the current example, but there will be, things after foundation models. And then the other thing is, if you think about hybrid cloud, where you say, I want to be able to run in any cloud, but also on premises and also on the edge, this allows you to substitute implementations on an accuracy versus footprint trade-off analysis. So sometimes your use case is accuracy trumps everything else. I mean, accuracy of inference. And you're going to run in the biggest honking hyperscaler you can, and you're going to spin up as many virtual machines or containers as you can in order to achieve that accuracy. Then on the other end of the spectrum is an edge use case like our Watson orders. Watson orders is a appliance, software plus hardware, that runs inside McDonald's to do speech to text and text to speech for orders at McDonald's, like if you order fries. And a key architectural point of Watson orders is that it can't have an internet dependency because of latency, or the extreme version of latency, which is a data center goes down. Imagine how awful it would be if the US East Coast couldn't order French fries for a morning because our data center in Virginia had a hiccup. So for that, you need a smaller footprint because it's edge, but you still need good enough accuracy. And so with this architecture, you can substitute in the edge optimized implementation while maintaining the same API. So that's how we got to now and where we are. So what's next? I'm just going to give a little preview of Rob's talk, and then I'll be quiet and we can have a discussion. So this is how we think about ChatGPT inside IBM. And if you're younger, this may not be very meaningful to you, but if you're of my vintage in your 40s or 50s, then it'll be more meaningful. So the web came out in 1993. Tim Berners-Lee invented the three fundamental technologies, HTML, HTTP, and URL in 1993 at CERN in Switzerland. But it wasn't until Netscape came out as the first really awesome web browser and frankly added new features to the web like images that people really saw how magical this web platform really was. And it really created a whole new kind of sub-industry in tech, e-business, new ways of doing transaction processing, e-commerce, but it became a ubiquitous technology, but it really only got the world's attention because of Netscape, even though Netscape is now an important footnote in history. So that's how we think about ChatGPT. What I didn't share in the presentation is that also in 2021, we started a separate thread of investment around foundation models. So foundation models, again, this is the next paradigm shift that allows you to do things like ChatGPT, not solely, but a big aspect of them. And in 2021, we made a decision at the top of the company to go big into foundation models. We knew it would take a couple of years, but we made that decision. And so for us, like you might think that we would look at ChatGPT as a scary thing. It's like, oh my gosh, what's this going to do for Watson? But we actually look at this as the Netscape moment for AI, in the sense that now it's got the world, like literally the world, realizing how powerful AI can be. And what we really want to be is the world's best AI provider for trustworthy AI. AI that is safe, AI that is verifiable, AI with great data provenance, such that it can be infused in critical business processes that affect human outcomes. And as just kind of a silly analogy, ChatGPT is awesome to ask it to generate a poem about, like, how can I write a poem about my daughter, but in the voice of a drunken pirate. I would not trust ChatGPT to fly an airplane that I was writing on. So amazing technical innovation, and it's got the world's attention, and frankly, it's inspiring us in some ways. But we really want to major on that trustworthy AI for business, but making use of many of the same technical underpinnings. So with that, I will just say Rob's going to talk to you about what's next, and I hope this talk was useful to you. So I'm going to stop sharing my screen, and we can do Q&A.
That was awesome, as I was expecting. So thank you so much, Bill. I've got a few questions. Of course, with ChatGPT, well, you took care of it, so I can scratch this one off. Now, with all the models you've described there, how do I start?
So I guess it depends on who you are. Let me tell you, like, the person we're optimizing for. So we're optimizing for the application developer who knows little or nothing about AI. And it's a really interesting problem because I've studied the topic of human expertise quite a lot, and now artificial expertise with AI. And one of our problems as humans is that we establish mental models of the world in order to just get around and do our jobs and survive. But when something fundamentally changes, it actually creates blind spots. And so what I realized was, when I started the job in Watson, I was early 40s, now in mid 40s. I had a complete blind spot that AI could actually make applications better, even if you don't know about AI. Because what you can do is you can package up very powerful AI models and wrap them with APIs that look like any other API. So as an example, I fly American Airlines a lot, and sometimes it doesn't go great, and sometimes I complain. I complain on the website. When you go to the website to make a complaint to American Airlines, and you can do this, you can try it right now, it actually asks you to categorize the nature of the feedback. Is it a complaint or is it a compliment? And if it's a complaint, is it about the booking experience? Is it about the boarding experience? Is it about the in-flight entertainment? when I look at that as somebody who now understands AI and natural language processing, I look at that application and I say, why are you asking me? You can use natural language classification and just classify it yourself. Or at least maybe you just let me type my blob of text and maybe you ask me to confirm that that's what it's about. But like, why are you asking me? But I actually know the people who run the American Airlines application, and they're like I was before I joined AI. Like they're in their late 40s or 50s, and they grew up in an era where AI wasn't practical. And so we just learned traditional programming, and now that AI is practical via APIs, we just don't think to say like, oh, this could be much better because it's not part of our mental toolbox. So really, there's gonna. And I think this is kind of a generational problem that'll kind of sort itself out naturally. But we can, just because like now when you go through like a college degree for computer science, you actually have AI courses because it's so mainstream now. But for the older generation like me, I think there's kind of an unlearning exercise and a relearning exercise to understand how AI can be brought to bear to make applications better, even if you don't know anything about AI. And the design point we're going for is that the 80% case should be just use the APIs, which requires no understanding of machine learning life cycle. I mean, you do have to know what it can do. Like you have to know what sentiment analysis is and what it's good for. You have to know what entity extraction is, what it's good for. But otherwise, it's just APIs. And then the 20% case is data science customizations where you do need a bit of data science. But most companies have data science teams that can augment the application team. So largely it's about bringing the power of AI to the much larger population of application developers, because it basically is the way you attack the skills problem, the skill shortage problem at scale.
That's a great answer. So basically, when you were saying what skills for the application developer, that's what, Java, Python, things like that.
Yep.
All right. So, when you were talking about inner source and all that, how did you gain momentum? Did you was it a cart, or was it a stick, or a bit of both, or how did you motivate people to join on your journey and do something?
So there's an answer of how we did it, and then there's the answer of how I do it, knowing what I know now. I'll give you the answer of knowing what we know now, because it was a lot of fumbling in the dark in the first couple of years. So this may be a special case for IBM, but let me just tell you the IBM case, and you can see if it generalizes. So we have a research group and we have a software group, each of which is multi-billion-dollar investment. But the nature of the software group is they have to build products, and so they don't really get investment for fundamental innovations. The IBM research group gets investments for fundamental innovations. So the organic innovations in IBM originate with IBM research 95% of the time, and anywhere else the other 5% of the time. And so as a control point, the VP of Research AI, who's now my manager, I actually moved over to the research division last year, he said any new major investments have to go into this common stack. And he was the boss, so he could just make that call. And of course, people grumbled about it because, people always grumble about change, especially if it imposes constraints on how you work. But by doing that, when the product teams would come to us and they'd say like, hey, we need an amazing new NLP innovation for AI ops, we'd say, cool, adopt Watson NLP. And initially they'd say, well, we just like working with Sheila's research team. Let us just work with Sheila and she can just give us the code as she normally does. And the research group said, nope, use Watson NLP. Sheila will put her code there. And so by doing that, it became the only way that you could get significant investments from IBM research. But then as people got familiar with it, they're like, oh, this is better because I just get updated components and it's just like adopting normal software. But then the other thing it did was, as more products adopted the common components, all of a sudden the researchers actually tried to get their innovations into the common components, because the researchers are measured on impact, and the common components, as they got adopted by many different products, became sort of like the easy button for impact. It's like, ooh, if I can just get my new NLP algorithm in Watson NLP, then I've immediately got 30 teams in IBM who could potentially adopt it. And it's much easier to get somebody to bump a build and call a new API than it is to do a net new adoption of a new technology. So that network effect of first forcing product teams to get innovations through the common components, and then the desire of researchers to get code in the common components for greater impact became a very powerful flywheel. The other thing I'll say is that we had amazing senior executive support. So Rob, it was actually the guy who's about to talk, Rob, it was actually his vision that we embed AI in all of the products. He didn't tell us to build a common stack. He said, figure out how to embed Watson in all the products. And a common stack was we determined was a necessary prereq to doing that. And so having SVP air cover and support by somebody like Rob was just great. And Dario as well, Dario Gill, our head of research. If not for the senior executive support, it would not have worked. So I think that's my short answer. I probably have a much longer answer to get into all the nuances, but that's a short answer.
All right. So I've got a question in the chat as well. So what do you see the most likely breakthrough to come from the intersection of quantum computing, and we're talking about Dario, and the harmonization of AI stack?
Oh, man, I actually don't have an answer to that. We've been so focused on the nuts and bolts of getting the AI stack right that at least my group hasn't started exploring that. But we will. I think it's just 1 or 2 years away. The one thing I will say, though, is that I can't share the name yet, but the name of the open sourcing of Watson Core is deliberately aligned with the naming of the open source foundation for IBM quantum computing, which is Qiskit. And they're being designed to work as a system. So we have, the way we say it is, we've got bits, neurons, and qubits, where bits are traditional computing, neurons is AI, and qubits is quantum computing. They're not, one doesn't replace the other. It's like, what's a better tool, a hammer, a screwdriver, or a wrench? Well, it depends on what you're trying to do. And so we're designing them to be 3 aligned tools in the toolbox. And the naming of the open sourcing of Watson Core will reflect that when it's announced in a month or 2.
So it's going to be Qiskit?
Something like that.
Okay. So speaking of the announcement for open source for AI there, is there any, can you summarize it? Because you know, okay, I don't want you to make the announcement here, but are we expecting something like if I understood, something like for AI orchestration? And
yeah, it's really just 2 logical things with a lot of bits inside the logical things. There are actually 3 logical things. So model serving or inference, like our model serving engine, and that's really, think of that as it's essentially like WebSphere for AI, in the sense that you put it on a server and it helps you run AI applications at scale, at internet scale. Because one of the hard lessons of the 2010 is that the people who can create world-class AI models are not the same humans as the people who can create internet scale systems. And so this model serving infrastructure brings those 2 worlds together. And part of that, a layer up, is the compositional runtime that helps you compose things together so that you can create interesting AI applications in a few lines of code rather than 12-month IBM consulting projects.
All right, that's pretty great. Can't wait to. Well, I wish I could go to Think, but I can't this year. You guys keep picking dates where I'm booked. The same thing last year. It's same thing this year.
I take no responsibility.
Terrible. But I'm planning on going to Think Exchange as well. Okay, so I hope to see you there. Yeah. And that's good. Remember. Any questions from the audience? People are very reasonable today. Wow,
amazing talk. Eh? This was so much information. It was almost information overload on AI and what IBM is doing. And I was really amazed by that. You're focusing on the foundation models as inner source, and then there is this kind of small wave regarding Hugging Faces. What do you think about Hugging Faces? They are actually distilling all the big models into smaller models that compute like 50 or 100 times faster than all those super huge GPT models. What do you think about this open source Hugging Faces company, and then their approach to the market by distilling and actually compressing those huge models?
Right, so Rob and Bill, I'm stopping you there. Rob is here. We have Rob for only 30 minutes. Okay, so Bill, you've got 30 minutes to think about the answer about that. Okay, so Rob, thank you so much for joining us.
Thanks.
And I think you've got the floor right away. Please go ahead.
I wanted to hear Bill's answer to that question.
Well, then you've got to stay after and give us more than 30 minutes.
Well, I actually haven't pitched Rob on the answer to that question yet, so I'd be pre-announcing something I want to pitch him on in a week or two. They're an interesting ecosystem partner.
I agree. Well, I appreciate the opportunity to talk to this group, and this is a very technical group. I think I know all of you well. So my presentation might be very uninteresting to you, but I wanted to kind of frame up what we see happening in the world of AI and what this means for business leaders. And we can certainly get into some of the technology, but I think we're at a very unique moment in time. And I think to some extent, our job, all of you, myself, is to figure out how do we talk to a business audience about this so that we can do what we want to do on the technology side. So hopefully I'll give you a few thoughts there that you can consider, and I'll leave ample time for discussion. Let me jump in here. I think the most unique part about where we are at this moment is this is the first time we've had the technology to where any company can build an AI interface to all of their applications. And when you do that, getting work done can be as simple as saying, open a purchase order, list new job requisitions, tell me my sales outlook, tell me my engineering productivity. This technology is actually there today to do this. And it wasn't, I would say, even as recently as 3 years ago. So that's what excites me about where we are. And to some extent, we probably all owe OpenAI a debt of gratitude for bringing AI back to the forefront. If you think about the history of AI, there's kind of been 3 seminal moments, I would say. First was Watson and Jeopardy, to kind of put it on the map. Second was probably Google and DeepMind. The issue with both of those, both the DeepMind work and the Jeopardy work, is people didn't really know what to do with it for their business after those. I think ChatGPT, it's a more relatable use case. Granted, it's primarily a consumer use case. And so I think the opportunity we all have now is to say, how do we bring this to the forefront in a business? This is some data we received from McKinsey that just talks about AI adoption. And it's gone up basically 2.5x in the last 5 years. I'm not sure we've seen any other enterprise technology on this kind of a curve, which also says that we're going to get to, near full penetration by 2025, which I don't think anybody thought was really possible just a couple of years ago. So I think that's interesting. And I was with a big CEO group last week in Asia. And one thing that stuck out to me from that conversation was AI used to be something that people would talk about their company and then say, hey, we want to do AI. What I hear now from every CEO is they want to be AI first. And I would say anybody with a level of imagination and a technical inclination has decided that being AI first as a company will be the source of competitive advantage going forward. And I think they're probably right. And so I think that is an opportunity for all of us to lean into as well. Let's talk a little bit about just the base building blocks. I think you all intuitively understand this, but not necessarily every group that I speak with does. So this may be boring to you, but let's talk about what the building blocks are here. ChatGPT created a lot of interest on the basis of a large language model. And that's just building models that are really good at text and natural language processing. There is, however, a much bigger concept here. And this is what we like to call foundational models. And you may have heard a bit of this from Bill, which is, how do we take advantage of a corpus of unlabeled data, apply all of the advances that have been made in transformers, and actually build models that can create new content, which gets to this notion of generative AI, which is anything that creates new content based on unlabeled data. And my view, our view, is that foundational models are going to take over business. So if you think back to my point at the start on, or just a moment ago, on companies becoming AI first, I think they will do it in one of the 4 lanes on the right side of this, or perhaps all 4, which is large language models, largely using that for customer service and serving employees, AI ops or IT operations, digital labor, basically automating different tasks of work that have to get done, or cybersecurity. So if you look at where we are in IBM today, these are the foundational models that we're investing in. Large language models, ready for prime time. We've been in production for 3+ years. AI ops, we are a bit earlier on. We've been in production really for 18 months. Digital labor, newer. I'll talk about some examples of that. Cybersecurity, newer. But this is how we're framing up the AI challenge for the stakeholders that we serve, being clients and partners. There is a huge opportunity around enterprise data. And I talked about the 4 that we're going to start with, but if you think about the data inside of an enterprise, ranging from sensors to images to code to geospatial to even material science, every one of these data sources could represent or be codified in a foundational model. So ChatGPT is interesting. I think the primary use case there is proving to be search. Maybe that evolves. But if you think about the companies that you all work in, or the companies that you work in, and you think about this broader opportunity around enterprise data, I think it's way more than just what can be done in enterprise search for consumers. These are the 4 use cases. So not a coincidence, but kind of where I talked about we're investing. This happens to be where we see the 4 business use cases: customer care, digital labor, IT operations, cybersecurity. Here's the secret, though. And maybe I'll call this a secret in plain sight because I think it's obvious to all of you. Nobody's going to own AI, no single company. Because the best AI is going to be a combination of bring your own model, open source models, and then maybe it's some models from IBM. Maybe it's some models from somebody else. But it's kind of bringing together all of those models, trying it, seeing what you get, tuning the model, building it out, continual evaluation, then deploying it based on wherever you want it to run. This is how foundational models are going to get put to work. So it's why I chuckle a little bit when people say, hey, we've chosen this company for our AI strategy. Like, I think it's a false choice. I think by definition, nobody wants to choose one company to work with. You want to get the best that anybody has and make it part of your AI strategy. That's how foundation models get into production. Just to give you a sense, what do we have today? So if you look at customer care, we really have 2 products that dominate this, which is Watson Assistant and then Cloud Pak for Data, which is where we do the data indexing. Digital labor, I think one of the best innovations we've delivered, some of you may have seen just in the last few months, is something called Project Wisdom that's inside of Ansible, which is code generation, code completion for Ansible playbooks. We're also doing things with like Watson Orchestrate, which is automating different tasks. So far, we've largely been focused on HR and finance domains. IT operations, Cloud Pak for Watson AI Ops is really the corpus of unlabeled data that we've brought together, trained on what we learn in IBM's own IT systems. On cybersecurity, I talked about that one's a bit earlier, but we're building that corpus of data. On infrastructure, for those of you fond of Z, I think the Telum processor is probably one of the best examples of AI in production, doing on-chip inferencing. We've recently built out a high-performance computing and a GPU cluster on the cloud. I think we're one of the few exaflop scale clusters, which starting in the second quarter of this year, we're going to be making available publicly so that anybody can access that. So that's a little bit of what we're doing. Where we're going with this, and I'll be candid, this is a bit of a work in process. But some of the work that Bill started about 2.5+ years ago on what we call Watson Core. This is basically all of the core elements, microservices of AI. How do we make it easier to do data curation, require fewer training examples, giving AI API access. Now we have something called a big AI workbench, which includes things like governance. Our platform strategy here is kind of evolving to be a mix of the foundation models I talked about, meaning if you want to adopt one of those models to go with the other things that you're doing, you can do that. But then also a set of developer services, and this may not be the final name, but something in the realm of what we're calling Watson Core, which is developer services for anybody that wants to build their own AI. That's essentially where we're going. How do you get started? We have a lot of clients that have started doing this. Bradesco is probably one of the largest implementations of customer care, using our core NLP engine, some of those developer services I talked about, doing conversational AI. I think last I checked, they were doing 200 million interactions, I think a month. So the scale's enormous. Digital labor, we've used AI, specifically Watson Orchestrate as an AI interface to our internal systems, largely in an HR use case so far. JB Hunt, if anybody knows them, I think they've done a lot in IT operations. Nova Group's a good example in cybersecurity. So I share this just to say, and I think you all appreciate this, but this is happening now. This is not like we think it might happen in the future. It's happening now, but it kind of comes back to that workflow I described of you got to be willing to try things, bring things together, tune and refine as we go. In terms of our roadmap, then I'll wrap up. Would love to take some questions. We're going to deliver against these 4 use cases here in the first half. As we get into the second half, it's kind of an evolution of some of those core services that I talked about. Maybe the more interesting roadmap is if you take this out to 2030. And as I would say to my team, this is more of a compass than GPS coordinates. So don't hold us specifically accountable, but the compass is AI goes way beyond NLP this year. We talked about that. As more people get in production, governance and trust is going to become, I think, an assumed inherent quality of AI versus something that you do separately. It has to become way more energy and cost efficient. And there's some interesting technology on how do you get GPU type performance without maybe what you sacrifice in terms of efficiency on GPUs. How do foundation models scale uniquely? What I mean by that is most companies will adopt foundational models trained on their own data. How do they get their own data and their own models to scale? Eventually, explainable AI will reason itself, meaning the decisions will be less about the humans. It'll be more about the AI doing the reasoning. That's pushing out a ways. And then we get to fully multimodal AI, which means by multi-mode, I mean any possible use case, edge, human interaction, structured, unstructured. That's where this goes in the much longer term. So let me pause there. I'd kind of love to hear what's on your minds, but I wanted to share a little bit on where we're headed as a company.
Hey, thanks, Rob. Yeah, we've got a few questions, and I'll start there. So, in one of your slides, you still, of course, you mentioned OpenShift. Is OpenShift getting a little bit simpler over time?
It has to, right? The tax on OpenShift today is it requires a lot of effort. But let me so a short history lesson, which many of you will appreciate. If you think about Linux circa 95, 99, somewhere in that range, it was a bunch of disparate pieces. It was really hard to use. Many companies tried to do their own. You eventually get to a set of, I'd say, standard approaches around how you do management, how you do logging, how do you do upgrades, how do you do installation. If you think about OpenShift now versus even OpenShift 3 years ago, it's dramatically easier, but that doesn't mean it's easy, to your point. But I don't think this is like a long way away. I feel like if we are where Linux was circa 2000, it took the next couple years, I would say, for it really to mature. I think that's probably where we are on OpenShift. So I acknowledge the statement, but I think how we get there is going to be different. So if you go back to kind of the example I gave around using AI inside of Ansible, can we use AI to do a lot of management for containers and orchestration? I think we probably can. So I think what used to be traditional management and automation of management, if we can apply AI, maybe we can move on the curve for OpenShift faster.
Very cool. So in 2019, you introduced I think it was 2019, the AI ladder. Do you think that with what Bill has been talking and where we are now, we're finally in the infused stage, or a much easier infused stage that we were before?
It's so different by company, by division, by organization, by project. It's hard to answer, I think, generically. What was this IDC stat I saw that said 90% of data is still unused or underutilized? Like, it kind of resonated with me because I feel like despite all of our effort on this topic, I'm not sure it's ever really been solved. Maybe it never will be, but that's kind of why I went to some of the core services inside of Watson Core, or things like data curation. That stuff is still heavily manual today. And I think until we get over that hump, it's hard to get everything operating at the infused layer, back to your question.
Do you mind if I add something to that, JGP?
Sure.
One thing that's different now versus, let's say, 4 years ago is that we now have a portable, embeddable set of AI capabilities for developers. Before, if you wanted something like Watson NLU, the only way to get it through was through the IBM public cloud. But because of the work that I described in my talk about getting to the modular, composable, extensible stack, now you can use a consistent API literally anywhere: IBM Cloud, AWS, on-premises, in the edge. And that's very, very powerful.
Yeah, it's a great link. My last question, and I know that Ralph has a few as well, is can we expect something like IBM's selling models as a service, or something like that? And is there, and as a follow-up of that, is there a standard on which something like almost a marketplace of models?
I think that's a difficult task to undertake because a model is only as good as the data. And we're not going to really build models based on data that we don't own, like OpenAI did. And and then try to monetize that. I think that's a really slippery slope. I think the way that I expect we will make money here is more about making foundational models available. It can be trained on data that we own. But I think, gold rush analogy, we want to provide picks and shovels. If we can help with the things that I talked about around governance, around data curation, around different use cases, Watson Assistant's more of an application. It has a model inside, but we're monetizing the application, not the model itself. I would see us going more in that direction, I think, than trying to monetize models, because I'm skeptical anybody will be able to monetize models themselves at scale, because the minute you do that, you're largely encroaching on somebody else's IP or data. I just think it's a slippery slope.
Yeah, I agree with you. Hey, Ralph, your turn. I know you've got a bunch of questions.
Yeah, thanks. Incredible talk, Rob. To get this idea where you're going, and this aligns with a question from Gaurav. He's asking, what kind of business alignment dash restructuring or what new roles can emerge when company says they want to become AI first?
I think the biggest thing every company has to look at is, what are the repetitive tasks that are done in the company? Repetitive tasks could be creating job requisitions, reviewing resumes, that type of thing. A repetitive task could be sourcing financial data, creating reports. A repetitive task could be negotiate with suppliers, drive to the best price, best quality. I think any repetitive task is going to be replaced by AI. And to the question from Gaurav, yes, that probably implies a level of restructure how work is done, getting alignment of the business. I think that's the place to start, though, is repetitive tasks. I think sometimes people want to take on, can AI tell us what to do as a business? I'm skeptical on that. It's like, that's more of a creative task. That's where art meets science, meets intellect, meets intuition. I don't think it's very good at that. In fact, it's not very good at anything that's creative, despite what you would see with things like DALL-E and Stable Diffusion. I don't think it's very good in an enterprise context. So I would just think about repetitive tasks. That's where the technology is going to go the fastest, I think.
Okay. So he then added one more point. If the IBM tools are so good, he says, how AI tools can be made more accessible. Yeah, sometimes he wants to just try it out and understand and figure out what does it mean for his enterprise, for his job. But he says, it's not much approachable to try it out by individuals, especially it looks like big enterprise tools that are not meant for trying out. Yeah.
I think it's a very accurate statement. Let me say, in our own experience, we weren't even doing a good job of making tools available inside of IBM. This is why we went down this model of creating Watson Core, and we used a term called inner source, which is basically creating open source access to technology inside of IBM to create access for our own employees, our own developers. We are going to bring this to the world. We haven't done it yet in terms of how do we make this accessible to developers, accessible via API, accessible as microservices. So that's work in process, but I accept your point. It's not there today.
Do you mind if I add one thing to that? So I told you all about some of the stuff from Watson Core that we'll be open sourcing in the May timeframe so that it could live at the Red Hat layer. You should really think of that stuff as the intersection of world-class AI and world-class internet scale computing, because the people who can do world-class AI can't do world-class distributed computing. And so when you put that in your servers, it makes it much more accessible to pull in models, whether they're your own models or third-party models, and run them in production. And so I think that thing, which is really derived from our last 12 years of experience since Watson Jeopardy, is going to be very valuable to the world.
Amazing statement. That's a big task that you have in front of you, to get all this to the end user and make it really try out now. And I want to have it in 5 minutes up and spinning, and want to fiddle around with it and play with it. That's a big task, I think. If I remember how long it takes to install a DB2 or IBM Cognos, to go from there, and you want to be there in just 1 year, amazing. A lot of work ahead.
I'll come back in June and give you a demo if you want.
Awesome. Take your hand on that. So we have one more question from Heather. What can we do to help companies create a plan to roadmap? What can we do to help companies create a plan, roadmap to make this happen?
I think it starts with, well, you can start in two places, and maybe you guys tell me what you think is more appropriate. One is you can start with the data discussion, kind of the slide I had around enterprise data. We can start there. Two is you could fast forward to the use cases. I'm pretty confident that every company will implement one or all four of those use cases in the next, I'll say 2 to 5 years, because companies are always slower than I think. So I'll say 2 to 5 years. I think either, depending on the audience, I would probably start in one of those two places, just to give people confidence that this isn't a science project. It's a specific problem based on unique data that you have as a business. So I'd probably recommend one of those two starting points.
Okay, so start with a specific problem and take it from there. Huh? The company, the company and their needs, and take it from there. Okay. Yeah, great option. So do we have more question in the chat? I just lost a little bit my focus.
You have a few. I'll read the one from George. In the public sector, the AI business strategy need to supplement the growing lack of staff. Both program and IT COVID showed that the need for enterprise remote processes are critical. Will IBM and Cloud Pak for BA include AI focus on this global need?
The primary focus in terms of how we solve that today is in Watson Orchestrate. If any of you are open to trying something over the weekend, try Watson Orchestrate. I think you'll be blown away. And the reason I say that is some of the early adopter customers are not who I would have expected. We have Great Clips, which is basically a haircutting franchise across the US that's now using Watson Orchestrate. I don't think Great Clips has like the savviest technology team in the world. But they saw the opportunity of we can build a skill in Orchestrate and we can automate work, and that's going to make our employees more productive. The thought process was really that simple. And to me, if they can do this, any company can do this. And I say if they, because I don't, you look at like percentage of budget they spend on IT, it's not huge. It's not as much as most companies. So will this eventually show up in Cloud Pak for business automation? To the question specifically, I would say I don't know yet. That's more designed around, content-centric workflows, traditional BPM. We wanted a little bit of a lighter weight approach to this, which is just adopt microservices, build skills using microservices, which is why we're doing that inside of Orchestrate today. So I would just encourage everybody to give that a try if interesting.
All right, so George, you know what you're doing next weekend. If you want to postpone the call we have together because you want to play with Orchestrate, that's fine too. And another question, you mentioned AI governance as next year projected topic. Can you dive a bit deeper into this topic?
Today we do bias detection, explainability, model drift. So I'd say those basic capabilities, which is really about indexing or logging data from models and understanding how they're behaving, that technology is available today. I think the real challenge on AI governance is how do you connect that to data provenance and data quality? Where did data originate? How were decisions made on curating data? Because to some extent, you're too late in the process when you're just doing explainability and model fairness, because it all kind of starts with the data decisions that were made. So I think there's two sides to this coin on AI governance. Those are the two sides. I think the big advances over the next year will be data provenance and earlier in the AI life cycle, I would say.
Okay. So people seem to be a little bit shy. We don't have any more questions. Ralph, do you have anything on your end?
Well, I'm glad I was asked to join the Pi Day celebration. I think this may be my second one, but I appreciate you all allowing me to spend a few minutes here. And we'd love to follow up wherever we can.
Well, thank you so much, Rob. Are we going to see you at Tech Exchange?
Likely. I'm still waiting for some firmed up logistics, but Tech Exchange is really critical to me. I want to get back to, I think there was a time we did this exceptionally well as a company. It actually goes back a long way, 30 plus years. And then we got a little fragmented. I want Tech Exchange to become a really vibrant technical community. It'll still have the specialization of the different user groups so that you can focus on specific topics that you want. But I think having a large technical community together is really important. So I'm looking forward to it. I think the plan this year is we'll do two, one in North America, one in Asia Pacific. We may do a smaller satellite one in Europe, but we will get to the point that this is an annual occasion that covers all the critical geographies.
Awesome. So thank you, Rob, and well, hopefully we'll see you there. So.
All right. Thank you, everybody. Have a great day.
Thank you, Rob.
Bye-bye. Thanks.
Bye-bye.
Yeah, so we wanted to have this last part of the section, this AI on Pi Day, so we could chat with one another. So feel free to unmute yourself, ask questions to Bill, to Ralph, to myself, or anything that comes to mind. And this is really your time before we wrap up.
Yeah, I think it's we had really cool words from Rob, and your question about Tech Exchange. I mean, it was the question from kind of that. How can he try it out? I think it's a really cool opportunity to go to Tech Exchange and meet user groups and get hand-on labs right there. Huh?
Yeah, so I'm kind of looking forward to. I'm not looking forward to going to Las Vegas, but Tech Exchange is fine. Bill, do you have already plans for Tech Exchange?
When is it?
It's mid-September. It's a week of September 11th to 14th, 15th, and it's going to be in the MGM in Las Vegas.
I can look into it. The state of the people who work on AI platform at both Red Hat and IBM right now is there is no June, there is only May. We're all heads down for our Think deliverable, so there's not really, like, May is the event horizon. Like we're not sure what happens after that, but it's good to know about.
There's no forest anymore. Okay, so I get it.
But it's just because we're racing to the finish line. It's a really good feeling, actually. It's kind of the culmination of 4 years of work.
I've got a great question from Julius here. To what extent has the chat GPT phenomenon influenced sales activities, but also the sales strategies and focus of Watson-based products? And what is going on there at the moment? You touched a Bill, but maybe you can be more specific for Julius.
Yeah, sure. And it's too bad Rob's not here since he's actually in charge of sales. But I'll give my answer as somebody who knows a bit about this. So the way I think the Netscape analogy is a really good one. That's one that Arvind introduced. And so literally CEOs are calling people like Rob and Arvind and saying, explain this to me. Like I played with it. It's really cool, but what are the implications to my business? And so we have an internal asset, which is basically how do you respond to ChatGPT inquiries. And it basically says like, okay, so let's first of all break down what it is and why it's powerful. Because sometimes people, especially non-AI people, can't really reason about like it feels different, but I can't really articulate why it's different. And then you get into like the paradigm shift that is foundation models. You get into the paradigm shift that is generative AI. But then you pivot to, okay, so how can I use this for my business such that it's useful and also so that it's safe? And that's where you get into the IBM approach to foundation models, which is much narrower, but also much safer. And the analogy I use is think about the difference between a scientist, like an expert scientist, and sorry to use a little bit of profanity, but a bullshitter. So a bullshitter pretends to know a lot about a lot, but if you actually have deep expertise in a topic, you realize they don't know what they're talking about. Whereas if you don't know about a topic area, it's like, that sounds pretty plausible. Whereas if you ask a scientist a question, like say you're talking to a scientist who's a scientist of chemistry, if you ask them a question about chemistry, they'll give you an amazing answer and they'll be able to cite the sources about why they believe that's the right answer, from the scientific method, experimentation, et cetera. If you ask them a question about physics, they'll say, oh, that's not my area of expertise, but my colleague down the hall is a physics PhD and you should ask her. And so the IBM approach to foundation models will be to have more task-focused foundation models and applications, but something that you can really trust because you'll actually have the trail of data provenance, the explainability of how it came up with its answer. So it actually will be safer to use in mission-critical use cases rather than like somebody who could kind of like talk their way into an airplane cockpit, but doesn't actually know how to fly the plane. I don't know if that answer is helpful or not, but that's the way I think about it.
Yeah, sorry. Snow, winter, internet problems. So, Robin, and you just mentioned data provenance. Okay, so how is that different from data lineage, or is it just the same thing?
Oh, I'm not actually, sorry, now I'm going to do the scientist thing. I'm not actually an expert in this area, so I can't explain the nuances of the difference between them. But my layman's understanding is that they're in the same zip code.
Okay, that's fair enough. That's fair enough. Any other comments, questions, Ralph? You always have insightful comments, Ralph. And I think
technical questions, yes, from my side.
You've got to provide content for Ralph, for the forecaster.
Yeah, that would be really cool to have a demo on this. I take you on this word, huh? Yeah. So the question that I asked before is going into the direction that Gandalf also mentioned there. How do we make all this accessible? And is this ChatGPT an interesting phenomenon? But what about the foundation models? Isn't IBM behaving here with its inner source ID like a gatekeeper? How do you at IBM decide on a good model that goes into the foundation or will not make it into the foundation? Why is the BERT model better than Roberta model or should we take both of them into the foundation? How do you actually manage the amount of knowledge that you need to decide on what goes in and what doesn't?
Well, there's both the code, like the code that we write, and then there's also the data that we collect and curate. And so the code that we write, we have a standard suite of QA benchmarks for model performance, model accuracy. And so for something like sentiment, it's, at the end of the day, we have a glorified test set that we can run a model against and say, is it getting better at sentiment or is it getting worse at sentiment? And we have that for all of the different capabilities that we care about for NLP, for time series, for speech, et cetera. And so it's really just sort of fundamentals of the software engineering lifecycle and the data and AI lifecycle. Software engineering life cycles, how do we architect systems that are robust, modular, composable, extensible, performant, secure, all the normal stuff. And then with the data and AI life cycle, it introduces additional set of problems like, is this data safe? Is this data biased? Do we own this data? So on and so forth. So it's really just being good at those fundamentals, which is probably like a whole hour to talk about what does being good at those fundamentals look like.
Okay. Yeah, it's difficult. What I found is that I found those jailbreak intentions on ChatGPT that they're amazing, and how fast they actually fixed them. Do you think IBM will be at the same speed, or do you even prevent such jailbreaks and misinterpretations beforehand?
So I think you can make this answer about any complex system, whether it's a AI-centric complex system or, organization. All complex systems are always partially broken. There is no non-trivial software system that does not have bugs. And so I think of this in terms of two characteristics, robustness and resilience. And by robustness, I mean, we try to anticipate failures and have technical countermeasures against them. So just like simplest example, you never have a single web server in the web tier. You always have like 3 or 10 or 100 or whatever you need. And you don't expect none of them to fail. You expect all of them to eventually fail. And then you have something that will detect a failed web server, kill it, and spin up a new one in its place. So that's robustness. Resilience is less well understood, in my opinion. So in my mind, you actually can't have resilient software. It's not even a fitting adjective. What you can have is resilient socio-technical system. And that's the set of humans and the set of automations working together to solve a task, like run Amazon.com website or something. With resilience, the best you can do is have good, this is kind of a simple way of saying it, but good logging and then good log analytics so that you can, in the worst case, detect that something's going wrong. In the best case, predict that something's going to go wrong. Just like, we have, Apple Watches to help tell us if our heartbeat is kind of irregular or something. And so we will design our AI systems to be both robust for the things that we can predict, and we will have the logging, instrumentation, and analytics so that we can inform both the AI agents as well as the human agents that we may be drifting towards a problem. All that being said, no matter how hard we work, stuff will happen. Stuff will be found that we don't find first. And then the goal is to be as responsive as possible and as transparent as possible.
Yeah, really looking forward to that, because what I always find is users are so creative with your product when they start using your product and they find ways around it. And yeah, it's always interesting to get stuff out of the labs onto the road and people trying out new things. So really looking forward to see good IBM products hitting the road as you just promised. And I think they're golden times ahead. You're completely right. I remember when Netscape was out there, came out, we had this first proof of concept browser from to Berners-Lee, it was working somehow, but it was not good. And then all of a sudden we had Netscape, and then all of a sudden JavaScript was working inside the browser, and we could do programming in the browser. And but it still took 30 years almost to get those hybrid web apps that we're using today. And I think you're completely right in saying it's a very unique moment that we're at with the AI development and all the different models, and your approach to joining together those transformers and parsing them through the intelligent models and asking the right stuff to the correct model and asking for help and interpretation it's a huge approach, and a very different approach than OpenAI is going, where they separate actually image comparison and creation from stable diffusion and large language models. They don't combine it. It's living in their own towers separately.
Yeah, that's one thing I'm like, if somebody asks me, how confident am I that IBM will be successful in enterprise AI? I'd say extremely confident, but it's not because of the technology. I mean, the technology is great, don't get me wrong. The real secret sauce is the fact that through this inner source process, we're actually all working together now. And I think that's the thing that's hard to replicate. Like when I frankly look at some of our competitors' websites, you can like see the organizational boundaries. And so I think getting the human collaboration right is the harder part. But once you get that right, then the technology being cohesive, coherent, we've got a saying that each thing has to be individually great, but the things have to be better together. Like you only get that if you first fix the human sociological problems.
Yeah, I think this is in a lot of technology these days. We're going back to the human and putting back the human into it. I think that was actually something that Seth Dobrin was telling us last year at in this exact event. I also love the analogy with Netscape, because if you're not in your 40s or 50s, you probably never heard of Netscape. But they were instrumental. And now the leaders, if you just look at that, the leaders are back to, I would say, you can think about Edge and Microsoft, or you can find about Chrome and Google. Okay, would kind of took away this part, so there's room for I would say a little bit more mature companies to get back to there. Bill, you talked a lot about NLP prior. Where are we on computer vision?
That's an interesting one. So, do you mean in general or at IBM?
More at IBM.
Yeah, so we had a visual recognition product that failed in the market in the 2010s, Watson Visual Recognition. And my analysis of why it failed was that it tried to out Google Google, which is a dangerous business to be in. And so it tried to have as good kind of like basic visual recognition tasks as Google for things like object recognition, et cetera, but without Google's like massive trove of images and pictures and videos that they train on. So that failed. And then in 2020 or so, we kind of famously said we will never do facial recognition again because of the ethical problems that exist that are just kind of like endemic in it. And so a lot of people think that IBM has given up on computer vision. That's not actually true. It's coming back, but in a non-obvious way. So we really care when, IBM's not doing consumer stuff. Like Rob said it, I said it, we're just not doing consumer stuff. But there is one domain where computer vision is incredibly important for things that we care about. And that's the domain of industrial businesses, as well as, I'll just stick with industrial for now. There's one with space exploration, but that's a little further out. Climate change, not space exploration. But industrial use cases are things like today, it's things like using our Maximo visual inspection software to fly a video camera across a bridge and look for and have the AI software find anomalies in the bridge that might require repair. And so we have a really special partnership between my Watson Core team and the Maximo team, who you can think of, I don't know if you know IBM Maximo, but the way I think about it is IBM's intersection of the software world with the physical world, and working on bringing the Maximo Vision AI technology into Watson Core so that it can benefit from the composition architecture that we have with everything else, like composed vision with trust, composed vision with time series, et cetera. So we're doing that, but I think there's a fun kind of longer term use case for that, which is industrial robots. So one of the ways to think about Watson Core, and again, like Rob said, that probably won't be the name that we go out with in May, but I'll just use the internal name for now. It looks, and sorry, this is going to sound pretentious, but it looks a lot like the human brain in the sense that it's got different areas of cognition that correspond to different tasks that the human brain tends to be good at. So it's got an area for natural language. It's got an area for time. It's got an area for explainability. And one of the reasons we designed it to be composable was, and I think these two things end up going together. So if you look at the way our brains work, they're highly composable. So when you just like look at a stop sign, say you look at a stop sign and you say, that's a stop sign. Just to do that simple task requires like 3 or 4 different major regions of your brain: the visual region, the language region, the spoken language region. And so I think with industrial robots, it'll really shine through to have this compositional architecture, because industrial robots need to see, industrial robots need to hear, and working together with a common artificial intelligence architecture, similar to how our brains have the different regions, but they all use the same, neurons and synaptical architecture. And so, sorry, I'm going off on a tangent here, but I get very excited about industrial robots.
And share your passion for sure.
Yeah, and industrial robots will be important for, like, the thing about industrial robots is there's the 3 Ds: dirty, dangerous, dull. Those types of tasks will really lend themselves to industrial robots.
Okay, awesome. Do we have more questions?
No questions, but Bill actually provided us a cool link. Good morning, America, 1994. What is the internet? I have to see that afterward.
It's so funny because they're like, what do you do?
Yeah, I remember the Red Hat video from 10 years ago, when they promoted open source and actually asked questions like quotes from Bill Gates about open source. It's never going to make it from the garage. It's for hobby freaks and nerds. And then all of a sudden they recognize, oh wow, there's an enemy here. Yeah, and hilarious spot from Red Hat, how they actually promoted open source and how they started, and how venture capital people asked them, how can you make money from this if you give everything away for free? And here we are. Red Hat is super economic, bringing super power to the IBM AI stack, and I mean, I think it was the biggest acquisition in IT history, wasn't it?
Yep.
Yeah. So this is where open source went, and I think you're completely right. We're in a very unique moment, and it's time to rethink everything. And as you grab it up, and as you put all this together, and promising to go open source with this, is going to be amazing. Going to be amazing. Right now, I'm always amazed looking at the Microsoft repos on GitHub. that Microsoft actually is overtaking Google and the amount of repos and amount of code publishing, and coming from such a closed source company, and that transfer in 10 years, amazing. So really looking forward to IBM keeping up his history and in publishing and contributing and to this space, to this new space also.
Well, one thing to understand, IBM is a very different company now than it was in 2019 when we bought Red Hat. And one of the reasons is that our current CEO, Arvind Krishna, who's been CEO since March 2020, I remember April 2020, he became CEO right after COVID broke out. He's the first, believe it or not, so IBM's a 111-year-old company. Arvind is the first CEO in IBM's history who actually has a background in computer science. And so, and just like everybody else, all the other CEOs were from marketing, sales, or services. And if you look at Satya Nadella, same thing, like he has a computer science background. And so both Microsoft as of 2014 with Nadella and IBM as of 2020 with Arvind have deep technologists. Like Arvind can like hang with anybody talking about information theory. And so because of that, he's been re-architecting IBM like you re-architect a monolithic system into a set of coherent microservices. And so our rate of execution is actually accelerating. Like the level of capability that I'm seeing right now in the AI platform stack is at a higher pace and at a higher quality, both higher quality and velocity than any project I've ever seen in my career. And it's actually accelerating. So anyway, I'm feeling pretty good about IBM. By the way, I shared this video. It's longer, but this is kind of to your point, how I feel right now. Alan Kay, for people who don't know who Alan Kay is, he's one of the legends of, software, helped create the GUI interface at Xerox PARC, was a mentor to Steve Jobs. And he has this amazing talk that I think is kind of forgotten to history, but I watch it every now and again, called "The Computer Revolution Hasn't Happened Yet." And what you see is a very grumpy Alan Kay on stage, basically complaining about the software of the day, like Windows and C++ and web browsers. And he said his basic point is like what he can envision for computing, like we haven't even started there yet. And I think we're at this moment where the world 2-3 years from now looks very different because of the infusion of next generation AI. And so I think you could almost like bookmark this video, and then like 3 years from now, look back and just say, what's different? And it's going to be very different. So I think Alan Kay's statement is still true. The computer revolution hasn't happened yet.
Yeah, totally cool. Totally cool. I took this also on the forecaster GTP. Yeah, I wrote in the last forecaster in the issue number 9, I wrote, what will AI be for us in 10 years? Yeah. What would that mean if we had personal assistants actually helping me to manage my chaos at home? And what does that mean for the storage of the data? And what does it mean if the AI then all of a sudden has feelings? And what happened at Google, that they say it developed a consciousness. Yeah, will this be happening in 10 years? And how do we deal with this? It's an amazing time we're living in right now. Yeah.
Yeah. Well, I think the term that is used often is artificial general intelligence. That's what a lot of people use to say like when computers surpass humans in terms of intelligence. But I prefer Jan LeCun of Facebook's characterization, which is just human level intelligence. And the point he makes is that, and Rob kind of made this point in a different way, for creative tasks, there's not too many things that happen where an individual human does a massively creative task. Like we work in teams. Like if you think about the Apollo moon missions, that wasn't just like a single pioneer. That was a whole team of mechanical engineers, computer scientists, to do things creative. So I think what'll end up happening is I think human level intelligence AIs are inevitable, like unless the human race somehow manages to go extinct before then. But I think it'll be a collaboration. So a collaboration between humans and artificially intelligent agents, not sort of one replacing the other. Anyway, we'll see.
Hopefully the world will not end, and let's try to finish on a positive note.
Yeah.
So thank you everybody for joining. We're actually at time, and I really thank you so much for joining. Well, this was AI on Pi Day by AIDAUG, and you can join us at aidaug.org, and we will share the recording sometime on YouTube. And so thank you very much, Bill, who stayed the whole thing. That was kind of unexpected and really appreciated. And also to Rob Thomas for joining us. So thank you guys, and stay tuned for more coming from AIDAUG. Bye now.
Thank you.
Thank you. Thank you. Bye-bye.
Artificial intelligence.
Data. Analytics.
User group.
AIDAUG.
Join AIDAUG today.